Here is the answer to the day 2 bell work. Let's see what you can do with multiplying or dividing decimals. Simplify each. Simplify means to perform the operation to make the answer as simple as possible. Question A, 20 times 0.5. The first number is 20. The second number is 0.5. The operation is multiplication. I know nearly instantly that this answer is 10. Now, if you also see how the answer is 10 just in your head, that is great. The reason I'm able to get the answer of 10 so quickly is I know that there's an equivalency between decimals and fractions. Decimals and fractions can be used interchangeably to represent the same mathematical concept, a portion of a number. Because I know that 0.5 is the same thing as the fraction 1/2, it allows me in my head to think about what is half of 20. Now, sometimes this technique about thinking of a decimal in terms of a fraction doesn't actually help you get to an answer quickly. Maybe the numbers are too large, maybe the fraction is too complicated, not something we're fluent with, like 1/2 of something, 1/3 of something, or 1/4 of something. In that case, a problem like this can be done on paper. 20 times 0.5, and then perform the multiplication algorithm that you learned in elementary school. 5 times the 0 is 0. 5 times the 2 is 10. Tally up how many digits are to the right of decimal points in the problem. Only one digit. And put the decimal point into the answer so that there's one digit to the right. The answer is 10.0, and that's the same thing as my answer of 10. Now question B, 5 times 0.4. Again, when numbers are written side by side with a parenthesis, but no other operator like an adding sign or a subtraction sign, that implies multiplication. This question is asking us to figure out 5 times 0.4. Well, does thinking of 0.4 as a fraction help in this problem? It does if you know that 0.4 is the fraction 2/5. Because it's easy to go 5 times 2/5. 2/5 of 5 is 2. But what if you don't recognize that 0.4 is 2/5? Or what if you know that that is 2/5, but you're just not very good at figuring out 2/5 of 5? Then you can write out the problem on paper. 5 times 0.4. 4 times 5 makes 20. In the problem, there is one digit to the right of the dot, so you put the dot into your answer so that you have one digit to its right. 2.0 is the same thing as my answer of 2. Now question C, 2.5 times 2.5. That's 6.25. Well, how did I get that so quickly? It's because I've taken the time to memorize some commonly occurring multiplication facts. Now, I didn't memorize 2.5 times 2.5 equals 6.25. The fact that I had memorized was that 25 times 25 is 625. Now, you might think, why would anyone memorize this? It's because in Algebra 1, you have to square a number frequently. That is, you have to raise a number to the second power. In Algebra 1, you will frequently encounter 25 squared, and you'll see it enough that it's worth your time to know that that's 625. How did I know to put the decimal point after the 6? Because in the original multiplication problem, I tally up how many numbers are to the right of the decimal points. There's one number here to the right of a dot and one number here to the right of the dot. In total, I need two numbers to the right of the dot in my answer. Now, with your current level of memorized math facts, you maybe weren't able to get to the answer like I did. In that case, you could write out the problem 2.5 times 2.5 and proceed with the normal algorithm that you learned in elementary school. 5 times 5 is 25. You write the 5 and carry a 2. 5 times 2 is 10, plus that 2 is 12. You start another row with a placeholder of 0. And then you use this 2 and multiply it to the digits in the first number. 2 times 5 is 10. You write the 0 from the 10 and carry a 1. 2 times 2 is 4, plus that 1 makes a 5. Then add together in columns 5, 2, and 6. To know where the decimal point goes, you look at the original problem. How many digits in total are to the right of the dot? And so you would put the dot here. Now question D, 10 divided by 0.1. I know that the answer is 100. Does thinking of the decimal 0.1 as a fraction help you to mentally do the problem? 0.1 is 1/10. 10 divided by 1/10 might be something that you can do in your head, especially if you understand that dividing by a fraction is the same thing as multiplying by the reciprocal of the fraction. Dividing by 1/10 is equivalent to multiplying by 10 over 1. This problem is the same thing as 10 times 10 over 1, and that's 100. Now, how would you do this problem if you didn't want to think about it in terms of fractions? You could use long division. 0.1 is being divided into the starting number of 10. To divide a number by a decimal number, the algorithm that you learned in elementary school is to transform the decimal into a whole number. 0.1 can be turned into the whole number of 1 if the dot was moved one position to the right. When that transformation happens, you take the dot, which is at after the 10, and move it one position to the right, filling in the spot with a placeholder of 0. Now the long division expression is 1 divides into 100, and that is 100 times. I want to ask you to think about something. Why would you ever want to do long division with decimals if there's a way using fractions that you can do a lot of problems in your head, and you can do them in your head faster than you'd even be able to type them into a calculator? So one thing to work on this year that'll really help you in Algebra 1 class is when you read a question and you're thinking about it, check to see, is there a way that you can do it in your head before you start thinking about doing it on paper or doing it on a calculator? Often there is a way that will work for you. Now question E, 0.5 multiplied by what number is equal to 1? What is the connection between starting with 0.5 and ending up with an answer of 1? How is 1 related to 0.5? It's twice 0.5. So the number you multiply by is 2.